So back to this problem. So now we're on step 3, and we've already gone from, we had a solid, this wasn't blue, we had a solid, and then we went from solid to liquid. That was our phase change. And now we have a liquid, and we're just getting that liquid hotter. So we're adding more heat to it, and we're getting a hotter liquid. So let's keep it in blue. So Q equals mc delta T again. So we know that M is still the 18.02. 18.02 grams, and the specific heat now is for liquid water, which is the 4.18 joules per gram Kelvin. And then our delta T here is from 100, we're going from 0 to 100, so we have 100 minus 0, which is just going to give us 100. And so when we work that Q out, we should get something like 7,520 joules, and we'll convert that to kilojoules. Let me just box our kilojoules before I lose them all. Divide that by 1,000, and if you can do that in your head, great, do it. We get like 7.52 kilojoules. Wonderful. Step 4. Step 4, now we have another phase change. We're here in green. Now we're going to go from a liquid to a gas. So all we're doing now is adding more heat. We're going from a liquid to a gas. The temperature is not changing, but we have a phase change, so we need to use another delta H. So our delta H of vaporization there times the number of moles. So I have delta H vaporization times 1 mole will just give us the 40.67 kilojoules. So it's kilojoules per mole times 1 mole just gives us 40.67 kilojoules. Great. And then our very last step here, we have a gas and we're just getting it hotter. We're going from 100 to 125. So since we changed the temperature, we're going to do another Q equals mc delta T. So we have Q equals mc delta T. The M is still the same, right? That's in grams, 18.02 grams. And if you get confused with your units, just look at, like, the C is in joules per gram Kelvin. Joules per gram Kelvin. So, and remember, the delta T in Kelvin is the same as the delta T in Celsius. So you don't have to convert these Celsius to Kelvin. The change in temperature is still going to be the same. So if you do that, if you do want to convert these, then you're going to convert this to Kelvin and this to Kelvin, and then everywhere along the way. It just makes it more confusing. The change, let me write that down, just the change in temperature in Celsius is equal to the change in temperature in Kelvin. Because you're looking at the delta T, you're fine just keeping it in Celsius, that's fine. So M, and now our C changes again, right? So our C now is for gas, 1.84 joules per gram Kelvin, and our delta T is 125 minus 100, so that's just 25 degrees Celsius. And so when you work all that out, you get about 830 joules. If you divide that by 1,000 joules, 1 kilojoule, you get 0.83 kilojoules. So if you look at these numbers, most of the energy is in the phase changes, right? This is 0.9, this one's 6, 7.5, and then 40. So this 41 is what's really, that's your big change in energy is happening when you go from a liquid to a gas, which is kind of what we expected. So when you add up everything that's in the boxes, you get your delta H equal to about 56.0 kilojoules. So that's your final answer. So these problems usually look pretty similar. You're making this melting curve. I'm just going back up. This one's a little bit cleaner. So again, you're going from, in this phase, you have a solid. Here you have a liquid. And then here you have a gas. So along those lines there. And then the horizontal lines, you have your phase change. You're going from a solid to a liquid. And here you're going from, from a liquid to a gas. So whenever you see a temperature change, so along that, that vertical change, you want Q equals mc delta T, and then along the horizontal line, when the temperature is not changing, but you're changing the phase of matter, then you want to use the delta H. So you're going to alternate between Q equals mc delta T, delta H, Q equals mc blah, blah, blah. And just remember that the M is the mass, the delta T is the final minus initial for that little piece, not for the entire process, but just for that little piece in that step. So break it up into these 5 different steps. Don't forget that if you had 2 moles of substance, then you would multiply your delta H by 2 or 3 or whatever, however many moles you have. And you are switching from grams to moles to grams to moles. So sometimes in the problem they give you grams, sometimes they give you moles. So just be careful of that. Don't just always assume that it's 1 mole or that it's, 1 gram. You have to read those units. They're going to be important.